tripod. Okay. So what you've got here is, I'll go through the pieces. You've got the 72 watt-hour battery pack sitting over here. It's got a little light that sits there and blinks. Okay. And then you've got two units that help simulate solar panels, and a third that simulates a solar panel, so these go back to power supplies. And then lastly, you've got a stack. So this stack is running, it's running a BeagleBone, the EPS you're going to fly, GPS you're going to fly. This board down here is an interface to the ADAX. One board that's not shown right now is called the PIM. And then this board right here allows this battery to be connected to everything. Okay. So right now we're just running along, and I can show you a demo over there with some software in a moment. Now what I'm going to do is I'm going to simulate the sun turning on. So I'm going to turn on a power supply over here. And you saw two changes. One is you saw this guy light up over here with a blinking bar graph, and you also see a little bit of power. So if I do the math, 0.1 times 21 is 2.1 watts, and I've got that basically twice. In fact, this is doing more. This is 0.2, so that's about, let me bring this down to the same voltage. Hold on, we're at 21.0. I'm going to bring this down to 21.0. They're going to equalize. So this was basically 3 watts and 3 watts. So you got 2 solar panels, each of which are generating 3 watts going into the system, helping to run the system. And there's enough power overall, because that's 3 watts in, and that's only taking about 1.5 watts. So there's a little bit of power left over, and that's why you see this light blinking right here. When that light blinks, it means the battery is charging. When that goes away, it means the battery is discharging. So if I turn this off, and we wait a little while, because that's not on, it's not blinking, we are now drawing all our energy from the battery. And once I allow some energy to come back into the system, now I can start charging it. So you're seeing the path from solar energy over here all the way through what are simulated solar panels into the EPS running the system. And similarly, I can turn on another solar panel over here. For reasons I don't quite understand, when this one is on and this one's on, you're not seeing it draw any power from this guy, but if I turn this guy off, now all of a sudden he starts generating the power. So we got 0.2 times 20, so it's about 4 watts going into the system. And again, there we are blinking away. So that's nothing particularly special. That's standard operation of a small stack that uses on the order of 2 to 3 watts over here. I haven't turned on the wheels or anything running them yet. And a battery is present. Now what we can do up here is we can see that in this case, this battery is sitting at 8.2 volts. Let me do something here. I'm going to... and all of the power from the battery is going and running this stack over here. But we also have the ability to pull some power off of the battery. We're going to do that. And so when I strike this blue button on right now, I'm now drawing 1/10 of an amp through this system. So in this box, I'm pissing away 1/8 of a watt, and over there I'm using about 2 watts, and I'm still charging. Now you guys are flying that Tegra processor, which is going to be on the order of, I think, 8 to 12 watts. So it needs a considerably larger amount of current, and it's going to draw it from the battery. So this is almost as if this was your Tegra that's going to run your cameras and do your processing. So I'm going to start cranking up its power, doing it in steps of 1/10 of an amp. Let's go up to an amp or so. So now we're drawing 8 watts out of the battery. Notice how the light went off? So right now with these 2 simulated panels, don't get alarmed, but with these 2 simulated panels, an 8 watt draw over here and about a 1.5 to 2 watt draw over here, it's not enough for the panels to keep you lit. And so the power is slowly coming out of this battery. And when we started, if I turn off this 8 watts, you're going to see this 8.14 number jump a little bit. Went to 8.2. 8.2 is the fully charged voltage on the battery. And now when I start to draw a little bit of power, this is normal for batteries, the voltage will drop a little bit, and current is flowing out into the load. In this case, we're simulating your Tegra processor. We're not charging anymore because we don't have enough solar energy to charge in this setup right here. And everybody's still happily running. Now I can go much, much higher here. We can go up to, let's go to, I don't know, 25 watts or something. Here's 25 watts. So you've got 25 watts out to your processor, processing away. Voltage has dropped to about 7.99 volts. Everybody's still running over here. Notice that these guys have stepped in and they're attempting to charge a lot harder. They're charging harder because they see the battery has dropped. So they see that lower voltage, they're trying hard, and what's happening is some of their power is going into this, some of their power is going into the battery, but not enough to charge it, and some of it is actually ending up over here. And all that happens automatically, whether you're in sunlight, in darkness, you're turning on your loads, you're turning off your loads, etc. Now, the really neat thing about this battery, in terms of how you guys fly, is you see this is a fairly large drop. This is about a 0.2 volt drop. I'll turn it back off, it'll get up to 8.2 volts. And if I turn it back on, we drop down to 7.98. If you were just using that number, that 8.2 or 7.98 as an indication of how much energy you had in your battery, you would not get very accurate predictions of how much energy you have to run your overall mission. But this guy actually counts how many electrons move in and out of the battery. And that's what this little bar graph is, this so-called state of charge. So right now we're on the last segment blinking, which means we're somewhere between 80 and 100% charge. And if I looked at some telemetry, it would tell me exactly what that was. I'm going to crank this up to something even higher. Let's go to like 4 amps. So we're going to see an even bigger drop here. But you'll notice that if I press the bar graph in a second here, if I force it to come on, I'm still getting 4 dots. Because it still has just as much energy as it had a few seconds ago because I haven't pulled very much out of it, even though the voltage dropped. So your flight software guys can use this to great advantage because what they can see is, okay, here we are, we've commissioned the satellite, we're on the 7th day of our testing phase, we want to do a 20-minute run of the VR. Do we have enough energy in the battery to do that? You can query the battery and it says, yeah, the battery is currently at the 89% state of charge. But perhaps even more sexy, it'll actually come in and say, it'll say, if you were to draw 4 amps from me, you could run for 42 minutes. The battery has that kind of intelligence. And you don't get that in these other battery packs because they're not.
This is a software API that can say that?
Yeah.
Cool.
Yeah. There's a full software API. I can, if I unhook this and go over there, you can see it. So that software API gives you this really great insight into where the battery is, what its status is, how much energy it has, etc. It's really cool. So that's a fairly unique feature that you have that is not really present in any of the other battery systems that we know of. So the EPS just marches along, does its thing, deals with these transitions going back and forth nicely. At the same time, you have this greater intelligence to be able to do all this.
Cool. Awesome.
So if we do that again, we can go, let's just do that again. All right, so there's 30, and then I think your radio was on the order of about 40 watts, so let's go ahead and pull something like 48 watts out of it. Okay, here we are. There's 46 watts coming out of it. These guys are stepping up to try to keep it charged. It's not charging anymore, but you are drawing those 40, let's go up a little bit higher, 48 watts. After a few minutes, this will turn on because it's getting hot inside because it's 48 watts. But this is more than adequate to run your radio.
Cool. Awesome.
Now, over here, I think I can show you a little bit of...
What's our status on solar panels?
Solar panels are built, sitting in a safe next door.
Sweet. Assuming we can resolve our stuff, when do you think we can get the whole thing?
I want